Good day everyone, we are group 4 from the subject Multivariate Calculus and we are going to present you our group project about the maximum and minimum values.
Assalamualaikum and hi, my name is AFIFAH binti AZEMAN. My number 3 is 280611. Today, I'm going to present about the introduction, which is background of study and key concept. For the background of study, what is multivariate calculus actually? Multivariate calculus is the study of calculus in one variable to function of multiple variable. Multivariate consists, differentiate and integrate two or more variable rather than a single variable. It's also one of the part of mathematics that give you knowledge about how input and output variable are related. To solve the multivariate calculus, we need to use the concept of partial derivative because it's very useful when we have more than one variable in the function. What partial derivative actually? A partial derivative of a multivariable function is its derivative with respect to the one of the variable while the rest are held constant. There are one application that use partial derivative to solve the problem, which is optimization. According to the Oxford Dictionary, optimization is a process or strategy for making something perfect and effective. But according to the Cambridge Dictionary, optimization is a process that aims to make something as good or as effective as possible. But in terms of calculus, optimization is to obtain maximum and lowest value given constraint. Optimization methods are used in many areas of study to find solutions that maximize or minimize some study parameters, such as minimize cost in the production of a goods or service, maximize profit, minimize raw material in development of a goods, or maximize production. For the key concept, partial derivative can be defined by using two methods. The first one by using the formula. For example, partial derivative of x equal to the limits h approaching to the 0, fx plus h y minus fxy divided by h. For the second method is by using partial derivative rules. For the product rules can be used if u equal to the function of fxy divided by function of gxy. But for the quotient rules can be used if u equals to the fxy divided by gxy. If u equal to the fxy power of n, we need to use power rules to find the derivative. However, if we have a three equation which is x equals to the gt, for example, x equal to the gt, y equal to the ht, and z equal to the fxy, so we need to apply change rule to find the partial derivative. So that's all from me. Thank you.
My name is Tan Kok Heng, lecture number 280730. I will take part in objective and methodology. The purpose of doing this report is to understand more about the application of partial derivative in our real life and try to use this formula to solve the problem encountered in life. In addition, students will be able to write detailed solutions using appropriate mathematical language. Students will also be able to determine the price and quantity of two products to minimize cost or maximize profit in the business and economic field. To find the maximum and minimum values, first we must find critical point. If let z equal to fxy and differentiate the fxy with respect to x as fx and respect to y as fy. A point AB is called a critical point of x if x equal to 0 and fy equal to 0. At a critical point, a function could have a local maximum or local minimum or neither. Then find the second derivative test. Suppose that AB is a critical point of fxy and then the second order partial derivative are continuous in some region. Next, define d equal to fxx fyy minus fxy squared. If d greater than 0 and fx greater than 0, then there is a local minimum. If d greater than 0 and fxx smaller than 0, then there is a local maximum. If d smaller than 0, then the point AB is a saddle point. In economics, the Cobb-Douglas production function is a form of production function often used to represent the relationship between physical capital and labor and the amount of output that can be produced by those input. If alpha plus beta equal to 1, then PMLMK equal to MPLK, which means that the production is also increased by a factor of M. That's why Cobb and Douglas assume that alpha plus beta equal to 1, and therefore PLK equal to AL power alpha K power beta. P is total production, L is labor input, K is capital input, A is total factor productivity, alpha is output elasticity of labor, beta is output elasticity of capital.
Hi, my name is Chanjiro with metric number 280580. I am going to present the first example of this project. First of all, example 1 is about maximizing Cobb-Douglas production function, where it is a function to model the total production P of an economic system as a function of the amount of labor L and the capital investment K. The general Cobb-Douglas production function is denoted as below. In addition, by using partial derivative, we can also obtain the marginal productivity of labor, where it is the changes in production output due to the change in the production input, which is labor, and also marginal productivity of capital, which refers to the additional production that the company could obtain when there is an extra unit of capital added. Example 1. Suppose the production function in medieval Europe is P equals to 30, L power of 0.9, K power of 0.1, where L is the amount of labor and K is the amount of land. The economy begins with 100 units of land and 100 units of labor. How much output does the economy produce? So for this question, we just have to simply plug in the value and we'll get the total production is 3000 units. What are the wage and the rental price of land? Since the real wage rate is the marginal productivity of labor, thus we need to apply partial derivative to the production function with respect to L to obtain the answer. We assume K as a constant and work for the differentiation. Real wage rate equals 27, which means that for an extra unit of labor, the production will increase 27 units with all other inputs remain the same. Likewise, the rental rate of capital is equal to the marginal productivity of capital. We have to partially differentiate the production function with respect to K by assuming L as a constant. So, for an extra unit of capital, the production will increase 3 units with all other inputs remain the same. So, here comes our main problem. Assume that each unit of labor costs 900 euro and each unit of land costs 1,800 euro. Suppose a total of 180,000 euro is available to be invested in labor and land. What is the maximum number of units of production under the given budgetary conditions? From the information given, we can build up the constraint like below. 900L plus 1,800K equals to 180,000. where L is the units of labor and K is the units of land. And then you simplify it, become 9L plus 18K minus 10,800 equals 0. Step 2, we have to construct a new function where we involve lambda as a new variable inside the function. So the new function will be involving the original production function plus lambda times with the constraint. Step 3, we should partially differentiate each variable. In this case, we partially differentiate the function g with respect to L and K, and then both equations equals to 0. After the differentiation and also the calculation, we will obtain two equations where lambda is in terms of variable L and K. Hence, we can equal both equations and solve it to get the relationship between variable L and K. The next step is to substitute the linear equation, which is the relationship between variable L and K that we obtained at the last step, into our budget constraint. This will result in obtaining the units of land and units of labor that will maximize the production. Here, 60 units of land and 1,080 units of labor is needed to maximize the production. Step 5, which is also the last step, we just have to simply plug in the units of land and units of labor into our original production function. We will obtain the maximum number of units of production under the constraint is 24,267 units approximately. That's all for my example 1. I will pass to SAFA for example 2. Thank you.
I will continue this presentation. By the way, my name is SAFA AFIFAH binti RAFIZI with the metric number 280749. I'm going to explain the example and analyze how to maximize the profit in an application of economic. Background of the problem: we want to know how to maximize the weekly profit for two brands of camping chairs. A profit function Z equals to capital P, PQ has been considered where P and Q are the selling price for brand A and the selling price for brand B. In this problem, we use first order partial derivative to determine the critical point, and we use second derivative test to find the D and relative extrema of the function. This is the question. A store sells two brands of camping chairs. The store pays 60 ringgit for each brand A chair and 80 ringgit for each brand B chair. The research department has estimated the weekly demand equation for these two competitive products to be X equals to 260 minus 3P plus Q, demand equation for brand A, while Y equals to 180 plus P minus 2Q, demand equation for brand B, where P is the selling price for A and Q is the selling price for B. How should the store price each chair to maximize weekly profit? What is the maximum weekly profit? First step is compute revenue and cost function because we want to find the profit function. So the total revenue is the quantity times with the price. By using the demand equation with respect to X and Y, we can substitute it into the revenue function. After we expand, we got negative 3p squared minus 2q squared plus 2pq plus 260p plus 180q. So for the cost function, we use the same thing. We substitute the demand equation into the cost function, which is 60x plus 80y. So we expand and we got 30,000 minus 100p minus 100q. After that, we add both equations to get the profit function. And the profit function is negative 3p squared minus 2q squared plus 2pq plus 360p plus 280q minus 30,000. Next, we use first order partial derivative because we want to find the critical point after this. We got negative 6p plus 2q plus 360 with respect to p, while negative 4q plus 2p plus 280 with respect to q. For critical point, we use both equation of partial derivative and equal it with 0. And we use substitution method and we got P equals to 100 and Q equals to 120. We can conclude that the critical point is 100 and 120. Next step, we use second derivative test because we want to check either it is relative maximum or minimum. This time, we use second order partial derivative with respect to PP, PQ, and QQ, which are negative 6, 2, and negative 4. To determine the D, we use this formula and we substitute the value we got before. And we know that the D value is 20 and greater than 0. And the value of second order partial derivative with respect to PP is negative 6, less than 0. According to the theorem, we can conclude that 100 and 120 is the relative maximum. Lastly is to find the maximum profit. We substitute 100 with respect to P and 120 with respect to Q into the profit function, and we got 4,800 ringgit. In conclusion, to maximize weekly profit, the store price for each chair needs to be 100 ringgit for brand A and 120 ringgit for brand B. Hence, a maximum weekly profit will be 4,800 ringgit. So I will pass on for the conclusion.
Assalamualaikum, my name is SYAHIRAH binti MOHAMAD FAIZAL and my metric number is 280786. I will take a part of conclusion. To sum up, companies may take different approach to maximize profits or minimize losses based on their organizational strengths. Calculus also allows the determination of a maximum profit by providing an easy way to calculate quantity and price needed to achieve maximum profit.